Hey class, thank you for joining in on the lesson yesterday. It was really nice to see all of you. In case you missed it, however, I'm going to give you this lesson again over a screencast real quick. I will try to make it shorter than the live lesson, but you can rewatch the parts that you don't understand. Okay? So, today we are going to review what we've been doing in class up to this point, which is describing bivariate data. Now, just as a review, right, what we've gone through so far is when you see a scatter plot that you need to talk about four different things, okay? The strength, the direction, form, and context, okay? A good way to remember this acronym is Sum Dum Frickin' Calculation. I know you guys like that. Looking at something that is relevant, right? This is the coronavirus cases recently. If you take a look at this scatter plot, the way that I would describe it is we have a strong, positive, curved relationship between the days that have passed since February 15th and the total number of coronavirus cases. That is how I would describe it. Oh, there it is. Okay, I should have had it. Oh, by the way, it is exponential as we talked about last time. Okay, strong positive curved exponential relationship between time in days since February 15th and the total number of coronavirus cases in the U.S. Actually, at this moment, the past couple of days, the number of cases has gone down, but we'll talk more about that during class today. All right, so what we're going to talk about today is we're going to add something new called the correlation coefficient. Now, what does the correlation coefficient add to what we already know? Okay, first of all, it is denoted by the variable r. Okay, some characteristics. What does it tell us? It tells us about the strength and direction of the relationship. Okay, so what does it tell us? It tells us strength and direction. And you probably guessed if r is positive, then the direction is going to be positive. If r is negative, then the direction is going to be negative. Strength is a little bit trickier. Okay, oh, it has to be in between -1 and 1. R must be between -1 and 1. The closer that r is to 1 or -1, the stronger the correlation. So for example, if you take a look here, r is -0.9, then it is a strong negative correlation. R is positive 0.5, it is a moderately strong positive correlation. Okay. Examples of what this would look like is this would be what? R is 0.9, this one would be R is -0.5, and this is R is -1, or in other words, this would be, we would call it a perfect correlation. This next slide is just more for you to look at, for you to be able to tell, like, oh, how can I tell if it's like 0.3, 0.8, 1, -0.3. This is just an example of what you can see, okay? Now, a question was asked yesterday that was really a really good question was, wait a minute, Mr. Shu, how do I calculate R? Well, we are not going to be calculating R by hand in this class. We will be using technology, and most of the time, I will give you the R value, okay? Because to be honest, I don't know how to project the TI-84 on the screen to show you how you would calculate it. And some of you actually don't even own a TI-84, so it's a little bit harder. So we're going to focus mostly on interpreting R, what it means, and how to use it, okay? But I'm not gonna test you on how to calculate it, all right? So don't worry about that. Okay, let's continue. So, how can we use this, okay? As we can see, we have this ridiculous situation here where we have fresh lemons imported to the USA from Mexico as our X variable and the total US highway fatality rate. Two variables that don't relate to one another. However, there's a correlation here, actually. So this is just another lesson that correlation doesn't mean causation. You need more than correlation in order to prove that one variable causes the other. Okay? However, if we have an r squared of 0.97, if I take the square root of that, I can know that r is equal to 0.98489. So therefore, we know that there is a very strong, because r is very close to 1, it's negative, okay? Oh, shoot. Because we know this is negative, I gotta fix this. I apologize. This should be a negative number, okay? Seemingly linear correlation between fresh lemons imported to the USA from Mexico and the total U.S. highway fatality rate. Guys, you guys need to know, I apologize, that this, and I'm not going to redo the video, but that is a negative number. My apologies. Okay. So, hopefully this lesson was helpful. Hopefully the video is not too big for this free software. But this is your homework. I want you to analyze it using SDFC and include your analysis with the R value as well. I will see you guys today this afternoon at 2:35. If not, I will try to screencast your lesson so that you can watch it on your own time. Thanks, guys.